Okay, I'm going to get started. I've got quite a few slides, so I'm going to go through fairly fast and ask you to hold questions unless you really can't stand it until the end. I'll try and get through with a few minutes to spare, and if worst case, you can chase me down at lunch and we can sit down and talk about whatever the questions you have. My name is Joe Conway. I'm the VP of Engineering at Crunchy Data. I'm a committer for Postgres. I've been around the community for many, many years. And I'm also the author of PLR. If you've ever done analytics with R, it's a procedural language handler that lets you use R with Postgres. This talk is about security, and it's specifically going to spend some time on something called the STIG, and I'll explain more what that means. But let me get a sense. How many people here have ever heard of a STIG? Okay, so a few. So we'll go into more into what that means. So the first thing I'm going to do actually is just cover Postgres and the ecosystem and the security features of that ecosystem. And the reason I say ecosystem, not just Postgres, is because if you're thinking about security, you need to think about the big picture. And if you're trying to lock down Postgres, things like locking down the OS are important too. So we'll talk about some additional open source tools that were made use of in order to publish the STIG that have to do with auditing and some other things that you can use to help enhance security. We'll drill specifically into what the STIG is and a little bit of detail about what's in there. The STIG itself, first of all, you'd be bored to death if we went through it in any kind of detail. And secondly, it would take hours. So we're just going to touch on kind of at a high level what the STIG is and what it's made up of and why it exists. And then I'm going to go through very quickly at the end. I'm going to try and hit on what are the PostgreSQL.conf settings that are related to the STIG or generally related to security. And I'll try and go through a little bit about the pghbeta.conf settings that are related to the STIG as well. And then I've got, you can see I've got 72 slides listed down there. I'm actually only going to try and go through 48 of them. Everything after that is in the appendices. In the appendices, I have some more specific information about PG audit, an extension called set user, and something that I'll touch on a little briefly that I call RLS time travel. So in terms of security features of Postgres, the first thing to understand is that Postgres actually has international recognition when it comes to security for a database. And this is significant certainly in certain industries and in certain government agencies. Postgres is the first purely open source database to have common criteria certification, which is basically a type of ISO certification for software security. It also has a published STIG, which, as I said earlier, I'll drill into more what that means a little bit in a few slides. And there is work in process for something called a CIS benchmark. This is the Center for Internet Security publishes benchmarks for security on various software stacks. And that's something that is being actively worked on right now. In terms of the security features, I'm going to break them down into perimeter, internal, and chronological. So the perimeter is, all the things about securing Postgres from the outside. The first thing that you should note is I start with the operating system here. There's a number of things you can do on the operating system that are going to enhance security of the database. You're trying to protect Postgres from all things, right? And in terms of the operating system to worry about, there's actually STIGs published for how to lock down the operating system. So again, depending on your compliance environment, you might be required to apply the STIG at the operating system level before you apply the STIG at the Postgres level. There's also something called FIPS 140. How many people here have heard of FIPS 140? So a few more. So that has to do with the types of encryption technology that are allowed to be used. And there's a way that you can configure the operating system so that only FIPS 140 compliant forms of encryption are used. And it's really encryption and it's cryptographic technologies because it includes hashing. Technically, hashes are different than encryption. Postgres itself makes use of discretionary access control, which basically just means file system stuff. The normal file system stuff you're probably used to. Postgres does not run as a privileged account. It will not run as root. It runs as an unprivileged user, usually called Postgres, can be called something else. But the bottom line is it will actually refuse to run if you try and run it as root. And it also has runtime permissions checks on the files to make sure that the files system that your database is in is locked down appropriately. Now, something else that you can do from this standpoint to lock down is you can use something called mandatory access control. And probably everyone in here has heard at one time or another of SE Linux. I'm guessing there's no one who hasn't heard of it. Probably very few people who don't absolutely hate it. How many people in here like SE Linux? Yeah, see, I see no hands. The thing is, SE Linux really is a powerful component when it comes to security. And I want to touch on a point here. I've highlighted in red that what I would recommend if you really care about security, you not only use SE Linux, don't disable it, but that you use something called the MCS policy. By default, on Red Hat 7, SE Linux is enabled, and it uses something called the targeted policy. The reason it's called targeted is because only certain services are actually controlled by SE Linux. And that's good. I mean, it means that if someone manages to compromise Apache and find some exploit that gets them a shell, that shell has limited access to the rest of the system. But what it doesn't do is it doesn't protect Apache itself from the rest of the system. And similarly for Postgres, if you're using targeted SE Linux policy, then if someone managed to break out of Postgres, they'd be confined. But someone on the rest of the system can still break into Postgres. If you lock down your system that way, I'm just going to show you real quick. Sorry. Is this big enough to see? What I'm showing you here is that as the root user on this particular system, I cannot look at the Postgres data directory. If things are configured correctly, you can lock it down to the point that the root user cannot even look at the Postgres directory, and neither can the Postgres user. So here I'm logged in as Postgres, and you can see that when I try and look at these files, I get no information about them. This is actually completely locked down in such a way that even logged into the system as the Postgres user, I cannot access those files. Only the service that's been started using systemd in a very specific way can access those files. So that's just that's my pitch for SE Linux. Don't disable it, embrace it, get people that know how to use it, and treat them well. Another form of security, perimeter security, is encryption at rest. This comes up a lot. Postgres does not have any way to natively encrypt data on disk, meaning like the entire cluster. There are some discussions on the Postgres mailing list about adding that feature eventually, but for now, you can still get that using file system encryption. There's kind of limited use cases that really protects you for, but in certain compliance environments, that's kind of the minimum standard, so you'd probably need to do that. Next form of perimeter security is the client-server security. So in terms of authentication, Postgres actually supports a wide variety of forms of authentication. It's something called host-based authentication. That's why that file that I don't know, I referred to earlier, the pghba.conf, HBA means host-based authentication. They're kind of standard built-in ones. I've got this MD5 one starred because, oops. One of the things that, according to FIPS 140, MD5 is not allowed anymore. The way Postgres actually uses MD5 is not nearly as bad as people tend to think it is, but just from the standpoint of the optics, there are a lot of companies that just plain say no more MD5. That's kind of the standard built-in way of doing password, quote-unquote, encryption. It's actually hashing in Postgres versions 9.6 and below. Postgres 10 actually has something called Scram that was added, And Scram makes use of more modern versions of hashing and more modern algorithms that are approved. And so that's actually, depending on the compliance environment you're in, that might drive you to Postgres 10. But the standard way to kind of work around that in those environments now is you can use all of these external methods, LDAP, Kerberos, GSS API. Basically, you can use Active Directory for Windows. You can use SSL certificates. So all of those are different ways that you can authenticate that will still meet FIPS or STIG requirements. In terms of encryption in transit, there's SSL. And later on in the presentation, I've got an example of how to configure your pghba.conf to use SSL, as well as how to make sure the client actually uses it as well. In terms of internal security features, once I'm authenticated to the database, how do I lock things down? There's standard DAC. Again, DAC is discretionary access control as compared to mandatory access control. Kind of means that whoever owns the table gets to decide who gets to look at the data. The system doesn't get to enforce that. Or the system enforces that, but the system can't override the person who owns that object. But in any case, Postgres handles this kind of standard database SQL method for doing grants and revokes on objects. There are users and groups. Actually, in Postgres, users and groups are really both just forms of roles. So there's a generic idea of a role that can log in as a user, a role that cannot log in as a group. These things can be nested hierarchically, so you can grant access to some role up here, and you can have a role down somewhere in the hierarchy below it, and that role will inherit the same rights. Or you can do things in such a way that the role does not automatically inherit them, but has to specifically escalate in order to get those rights. And then in terms of encryption internally, there's an extension to Postgres that ships with it called pgcrypto. You can use that if you want to encrypt like a specific column of a specific table. There's basically function calls. You pass your data through those function calls with appropriate keys. The data will be encrypted. Key thing to understand there, no pun intended, the key thing to understand there is that the key management is up to you and your application in that case. So the hardest part of encryption is really not so much the encrypting, it's how do you handle the keys in a secure way. That's where sometimes it actually makes more sense to let your application do the encryption. So if you've got an application that's running some kind of a Java library, there's all kinds of encryption libraries there. You can encrypt it at the application side and just store it as binary and then decrypt it back in the application. That way the data that's being stored is not being stored in the same place where the key to access it is. You hear people talk about transparent encryption. Postgres doesn't really have transparent encryption, but one of the things you have to understand is that if you're using a database that has transparent encryption and someone manages to hack into your database server, well, because it's transparent, they can read all that data. So again, that's why key management is really the hard part of this. Thinking about what threats you want to protect yourself from and how to do that is the key. You can't just think in terms of buzzwords and say, oh, I need to have transparent encryption because that's the latest and greatest thing. There's also, in terms of mandatory access control, there's an extension of Postgres called SEPGSQL that actually has bindings to SE Linux. And with that, you can do role-based access control to virtually all objects within Postgres. And if you add on top of that the fact that you can create your own custom SE Linux policies, it's possible to lock down Postgres in very significant ways that are not possible in any other way. For instance, you can lock down Postgres such that the Postgres super user cannot create a function, cannot access certain tables, and so on. So that's a very complex topic in and of itself. I've actually done talks on that before. You can find some of them on videos on the internet. But that is something to think about if you have those kinds of requirements. It is possible to do. It's just complex. And then starting in Postgres 9.5, there was a new feature called row-level security, which was added. And row-level security basically lets you, at a per-table basis, add a policy. And you can even add those on a per-user basis. Basically, that will determine, for every row in the table, when it gets queried, who gets to see it. It'll filter the rows. And in this case, it is transparent. So the rows will get filtered transparently based on the policy that you've created. And you can also control what rows can get created. So now the third kind of area of security that I want to address is what I call chronological. And here, this is really about history and auditing and those kinds of things. So the first place to start for chronological security is just the standard error logging and reporting built into Postgres. There's actually quite a bit you can do with that. Postgres can send the log to standard error. It also has something called CSV log, which can be really useful. Basically, the logs get output in a CSV format. The Postgres documentation has a table that you can cut and paste, a table definition you can cut and paste. And then since the log is in CSV format, you can actually directly import it. All those commands are actually right in the documentation if you use CSV logging. Be aware, though, that is fairly verbose, and so it can make the log grow pretty quickly. There's also support for event log in Windows, and there's support, importantly, for syslog or remote syslog. And so a lot of the requirements in things like the STIG require you to be able to ship your logs to a separate system under somebody else's control, and kind of the standard way to do that is with something like remote syslog. The other way you can do it, though, is you can use something like Logstash or Beats or Splunk, some kind of a software that does log aggregation and has an agent that ships logs is another method to comply with that kind of a rule. And then finally, there's this PG Audit extension. It's available on GitHub under, I think, the PG Audit organization. It provides for enhanced audit logging for Postgres. Basically, it gives you very granular capability, and it makes it so that you cannot easily obfuscate it. So, kind of if you use a PL/PG/SQL function, for instance, you could potentially craft SQL that takes two strings and concatenates together and then executes, and then so you might sort of fool standard logging with regex if you were trying to alert on access to a certain table. With PG Audit, you'll see that that table was actually directly accessed. So you can't get around it nearly as easily. You can also do that on a very object-specific basis. You can say, I want all access to this table audited, but I don't want all access to this other table audited. Now, there's also this area of, it's kind of overlaps with auditing. Lots of time you see people want to have some kind of history table so that every change that's made to a table gets logged somewhere in the database. And there's kind of a standard, more or less standard way to do it here with this trigger-based methods. There's on the wiki an example of how to do that. And the basic idea is whenever a row gets changed, the trigger fires, and then the row gets stored in either an HStore or JSON or something. Sometimes people will actually build a specific history table for every table, but there's a number of ways you can do that so that whenever data is changed in a table, you can preserve the old row. Another way to do this is something I've been thinking about for a number of years. I'm kind of inspired by a talk that I saw Magnus Hagender give a while back. I don't know how many people know him, but it occurred to me you could do this actually using time ranges and RLS as well. And I don't have the time to actually go through this in detail, but at the back in the appendix on these slides, I've got a whole section on RLS time travel, including all of the code basically you would need to go test it out. So the basic idea there is if you store a time range in every row and insert into a partition table whenever the row changes, you could have your history in one partition and your current data in another partition, and use row-level security to actually filter out all the old rows, so that whenever you access the table, you're just accessing the current rows. And if you wanted to view the old rows, you can either directly pull out of that history table, or you can set an environment variable that, or a custom configuration variable in Postgres. And once you set that, then that table will look as it did at that point in time. Okay, now I'm going to get into more what the STIG is and how that works. First of all, the STIG is it's something that is published by a US government agency called DISA. DISA is basically handles IT for the Department of Defense. And their mission is to protect data and make sure it's available. So they get involved in this security guides for all things software for the government. That said, there are many, many large commercial companies that, when they want to figure out how to go about properly providing security for their systems, will look to these government published specs and use those themselves. So we run into many commercial companies that actually have internal requirements to follow the STIG. The STIG is Security Technical Implementation Guide. They are the standards for the DoD, and they're, boiling it down, it's guidance for locking down your system. The STIG is made up of a number of rules, and each of the rules has a control correlation identifier. And basically what that gives you is a traceability for, here's a rule for how, that describes a concern about a vulnerability, and here's how you're going to check it, and here's how you're going to fix your system to make sure you can comply with this rule. And this CCI gives you traceability all the way back to NIST or some other place that specified why this thing is required. Now, the Postgres STIG was published back in, I think, February of this year, March of this year. It was worked on by Crunchy Data, my company, in conjunction with DISA directly. Just to give you an idea here, this is the page on DISA, basically, that has the database-related STIGs. And you can see there's this general database SRG. This is kind of the generic STIG for databases. Over the years on the Postgres list, if you follow them, you see people periodically posting questions. You can tell they cut and pasted them right out of there. By publishing a Postgres STIG, we've actually saved a lot of people work, because everyone who had to do that before, 100 and some odd times, very detailed, no longer has to do that. Now they can come down to this one, this Postgres STIG down here. You also notice with this list, the Postgres STIG is the only open source database on there. So it's pretty comprehensive guidance for how you can configure and operate Postgres in a secure way. It's based on that generic database requirement guide. As I said before, these controls derive from NIST and from other government publications. It's based on the assumption that you're running Red Hat 7, so RHEL. Technically, CentOS could meet these requirements, except for the fact that from a very technical standpoint, CentOS is not FIPS 140 certified. So if you really have the requirement to be FIPS 140 certified, then you would actually have to run RHEL. I think SUSE might have FIPS certification. I know Ubuntu is working on it. So there are other Linux-based operating systems that are either there or coming along. this thing was written specifically with RHEL in mind. So if you were going to use it on another system, you'd have to adapt it. It's written for Postgres 9.5 and above, and in part that requirement is because it does need PG audit in order to fulfill some of the requirements, and PG audit will only work on Postgres 9.5 and above. There's 111 of these rules, but it uses all open source components in order to be compliant. Like I said, we could spend way too much time talking about the STIG in detail. So here I'm trying to boil down what are the things that are generally covered by the STIG. It's talking about requirements associated with auditing and logging, as you might guess, encryption at rest and encryption over the wire, access controls, administration, authentication, and protection against SQL injection. So if you go through all of these things in detail, you'll basically find that they all fall into one of these categories. And some of it is fairly redundant. Another important thing to note is that the STIG, as published on this website, comes with what's called a supplemental guide, and in that are all the appendices. The appendices for the STIG are actually really useful because they include step-by-step information, for instance, how to set up PG audit, or there's examples on how to use RLS. So they're code samples and instructions. They assist you with the implementation of many of the things in the STIG itself that say, in order to fix it, you do X. Well, the guidelines for the details for how you do X might come from that supplement. And here's what the appendices cover. There's a sample lockout script. There's PG audit, as I mentioned, installation configuration, general logging and remote logging configuration, RLS, some guidelines on PG crypto, how you find and check PG data, and then SSL configuration guide, which is a fairly detailed guide for how that's done. So it does require RHEL and in order to be FIPS 140 compliant for the cryptographic modules. Just keep in mind that the STIG is just one component of a robust defense in depth. Just because you implemented everything in this STIG, it doesn't mean that you're 100% secure. As I mentioned, secure your OS, secure your network, security inside. Once you allow people to log into the system, you have to make sure everything's locked down at all of those levels to really have security. The main thing is to make sure that you train people in terms of good security practices so that people are always thinking in terms of security. The other thing is these rules and checks and fixes are fairly generic. It's difficult to write them in a way. I mean, some of them say things like, no one should be able to access data that the organization says that they shouldn't be able to access. I mean, I'm paraphrasing. But that's the way a lot of these rules are written, right? So it's kind of hard to write a check that says how to check that in a very generic way. So you're going to have to tailor these things to your own installation and interpret them in some cases to make them applicable to you. So now I'm going to go just into an example of a rule, basically talk about what one of these 111 rules looks like. There's some general information, which is basically title and identifiers, and it's got a severity category, which is probably one of the more interesting bits of that. There's a discussion section that talks about what it is that this rule is trying to protect us against. There's a section that talks about how to check to see if you're compliant, and then there's a section that talks about how to fix to make yourself compliant. And it's got a referencing section that talks about where this particular rule comes from. These severity category codes, category 1 is basically, so this is all with respect to confidentiality, availability, or integrity. So to the extent that security involves availability as well as some of the other things that we're talking about. If you can't get to your data, that's one aspect of security. Cat 1 is considered something that is going to cause that if someone exploits this thing, you would directly and immediately lose one of these properties. Category 2 is if someone exploits this particular rule, there's some potential for that to happen. And category 3 is basically it's going to degrade your ability to protect against loss. There is something called the STIG Viewer. There's a link here. I should have noted earlier that in the last session there were some questions about slides being available. And for one thing, all on my slides here, everything that's in blue is a hot link. The slides will be available. Generally, for every conference, there's a Postgres page on the wiki that is basically all of the past conferences, and then you drill into the conference, and there's typically a link for each talk, at least the ones that the authors post. I will definitely make sure that that wiki page exists before the end of the week and that I post my slides there. But you can also always find my slides on my own site, which is just joeconway.com. So this STIG Viewer, like I said, the STIG is a fairly complex beast, and it's hard to even look at in the form of like a spreadsheet or something. They provide this Java STIG Viewer, and this is what it looks like, but what I was going to do is show you, this is the actual app. So you can see each of those sections I talked about. I know this writing is really small. There's no way to make it bigger. It's not the most capable app in the world, but it does give you a way to kind of walk through these things and read them and see what each one is involved in. It also gives you a way to export, and so one of the things I did was I exported it to a RDF format that I could read into OpenOffice and then, you know, basically search for stuff. Okay, so there's also a project that we've worked on at Crunchy called the STIG Checker. I have the link here for that. I literally made that GitHub repo public about 20 minutes before I started talking. So it's now available to the public. It's not complete yet. It doesn't check all 111 rules. I think it checks about 80 of them at last count. There are definitely some improvements we could make in terms of making it more generically working for databases. Right now, it's some of the assumptions of what it's looking for are kind of hardwired. But the bottom line is it's based on Chef, and Chef has a module called Inspec, which is used for automation of compliance checking. And so this rides on top of that, and in the goal of this, once we finally get it to the release point, would be that you would be able to run in an automated fashion your checking against the STIG requirements and basically get back a green or a red. And we actually have this working in an automated way in certain environments in the government, but this is now, you know, this is the follow-on to that, and it's open sourced. And we also intend to do other versions of this later. I don't know how many people here are familiar with OpenSCAP, but Red Hat uses OpenSCAP to do similar things. We hope to have an OpenSCAP version of this at some point down the road as well, maybe an Ansible version as well. So now, this is just one of the rules. I just wanted to have an example up here so you could actually hopefully read it. I don't know if the text is big enough. But, you know, so this one is, the rule title is Postgres must be configured to prohibit or restrict the use of organization-defined functions, ports, protocols, or services as defined. You know, so this is very dense kind of stuff to read. But the bottom line is this rule, in our discussion with DISA, was interpreted as make sure Postgres is running on the port it's supposed to be running on, basically. All right, so here's more of the discussion, and then here's how you check it. You do show port, all right? And then the fix is you edit PostgreSQL.conf and change it so the Postgres is running on the port it's supposed to be running on. And you can also kind of locally change the port that your client uses using -P for your pSQL client, for instance. And then this references to the CCIs that where this particular requirement derives from. Okay, so at this point I'm going to go through related configuration items. There's no way I could go through every one of these in detail, so I'm going to go through them fairly quickly. There's basically 3 slides worth of, these are the configs that if you do a search in the STIG document that I talked about earlier that I pulled into OpenOffice, and you find all the places that we say check something that is in PostgreSQL.conf, these are the items. But kind of broadly, they involve the requirement to use PG audit, so that's loaded in shared preload libraries. There's a bunch of PG audit specific settings. There's other settings that are related to just general Postgres logging and what gets logged, where you log to, have a time zone set, make sure password encryption is on, SSL related stuff, and then some general things that generally have to do with not allowing denial of service, making sure that you don't have too many connections available and so on. There's other slides here that I've called other security related configs. I mean, depending on how broad your definition of security, like I said, security can be defined in terms of availability of data, which means things like if you set work mem too high and your client now basically can DOS your server by bringing it to its knees. So, I mean, there's a lot of things. There's some things that are very obviously security related. There are other things that are much fuzzier. But in general, things like where your configuration files are located, socket directory, Bonjour, which is automatic service discovery, authentication related things, row level security, Kerberos, work mem, different types of resource allocation. And another thing here to note is PostgreSQL.conf supports these, doesn't seem to be working anymore. Supports these includes. And so you have to be a little bit careful that it would be possible to actually look at your PostgreSQL.conf and think that you know what all your settings are, and then someone has an include for another file that overrides a bunch of your settings. So you need to look for that. A better way to check might be to actually log into Postgres and use show all or select star from PG_settings. Okay, getting down to the end. So now I'm going to touch on the pghba.conf. How many people here are familiar with the syntax and how that file works? And this one's pretty important for security. It's amazing to me how many features are in there, though, that even as a frequent user of Postgres, you may or may not be aware of. It's actually got quite a bit built into it. Basically, this file is going to determine which hosts are allowed to connect and how the client is going to be authenticated, depending on how they connect, which usernames you can use, and which databases you can access. The file is read on server startup, and you must reload if you change it. So you don't have to restart Postgres, but you do have to reload if you want the settings to take effect. And basically, the thing that you need to understand, probably the most important thing to understand here, is that this is a rule-based system. And so the first line in this file that matches the client is the one that's going to get used. Even if there are other lines down below that might also match the same client, they won't get used. So that surprises people sometimes. And if a line is picked and the authentication fails, then access is denied. If no lines match, access is denied. So I kind of think about this file as almost like a firewall for Postgres. This is the syntax. you've got a connection type, a database, a user, an address, a method, and then potentially options. And I've included on here the defaults for both Debian variants as well as Red Hat. The thing to note here is the defaults are, you're using, I guess my battery's dying. Oh, there it goes. You're using pure authentication or ident, which basically means that if the user is authenticated to the operating system and they're logged in as themselves and the database user matches the operating system user, they just get in, right? So it's also set up by default so that you can only access from essentially the local host. Depending on your organization, that might be considered secured, but it also might not. So the defaults here are not horrible, but they're not necessarily going to be secure enough. And they certainly don't meet the requirements in the STIG. The connection, so I'll talk about each of those columns. The connection is basically the type of connection that the rule is going to match. Local means a Unix domain socket, so it's not even using TCP/IP. Just as an aside, from a performance standpoint, if you can use that, it's actually somewhat faster than using TCP. Not a huge amount, but a noticeable amount. Host is basically either a plain or an SSL encrypted TCP/IP socket. Host SSL is going to require an SSL connection, and host no SSL is going to basically enforce the fact that it's not SSL encrypted. The database column, this specifies which databases this rule is going to match. And you can say all, which basically means all databases, but you can also say same user, same role. So this is kind of why the Postgres user, usually you don't have to specify the database, because the default, one of the default rules will normally match for the Postgres user on the username. There's a special word for replication. You can also name specific databases, or you can have specific databases listed in a file and then have a reference to that file. User is similar. You can use all for a wildcard. You can have a list of specific usernames that match that role. You can actually do any roles that match a group, or you can have a list of roles in a file similar to with the databases, and you can match that anything that's in that file. Address is going to specify which client host the rule matches. So this is really important for TCP/IP type connections. You can lock it down and say only this host IP address is allowed to connect, or you can say only this, basically this network using a net mask. You can actually use the keyword same host or the keyword same net to specify those two things. Or you can list an actual host name. You specify what method is being used. Trust, basically, this is authentication method. Trust means you let them in without any password at all. MD5, as I mentioned earlier, is kind of a hashed password that's stored locally in Postgres. MD5 is kind of persona non grata these days, but it still works pretty well. We could have discussions if you're interested in why I say that. You can meet me at lunch and then we can talk about it. But it's basically not as bad as it's made out to be, at least in the way that Postgres uses it. You can also specify post password, which is actually an unhashed version of a password. You definitely shouldn't be using that these days. Cert is for an SSL cert. Peer PAM and ident are kind of these OS-based, I'm logged in, let me in kind of authentication methods. GSS, SSPI, LDAP radius are kind of external systems that you might want to authenticate against. And you can specify reject. Anyone who matches this rule should be rejected. Depending on the authentication method, there are options. They vary by method, so I'll show you an example of that for LDAP here, I think next slide. So you can see here, that basically the options is used for specifying how to connect to your LDAP server, right here. So the ones that are STIG related here, auth method of password is explicitly forbidden by the STIG. The MD5 method is not like explicitly banned, but by the fact that FIPS 140 compliance is required, it's effectively banned. You have to use the auth method of CERT, GSS, SSPI, or LDAP unless you can get some other method justified and approved. Every role has to have a unique authentication requirements, and login roles should not be shared. If you're using the method of CERT, the host SSL entry must contain ClientCert equals 1, which basically means that you're requiring there to be a CERT on the client side that you're authenticating against so that you've got only valid clients. And a CRL file must exist and be used. So in this example here, you can see this rule basically matches what I just talked about, and then when you connect as a client, this is how you can do it. And this SSL mode verify full means that the client is actually verifying the server as well as the server verifying the client. And I actually got through all of my slides with about 4 minutes to spare, so if there's some questions, I'll be happy to take them now. Actually, can you come up to the mic? Because this is being recorded.
You said for authentication, you said you can't use MD5, but you can use LDAP, I guess, for...
Is that thing on? I guess it's not working. All right, go ahead. Sorry.
So you said you can't use MD5, but you can use password. But you can use LDAP. When LDAP actually connects, like you're trying to do authentication, it actually sends a password request to send it in plain text, though, from the client, right?
You can use a secure LDAP.
But from a client, if I use PSQL to connect, let's say, if I'm using LDAP to authenticate, if the server's going to use LDAP, it'll ask me for my password in plain text, though.
Right. So you use SSL to connect between the client and the server.
So in that situation, though, that's like based on, I guess, with the FIPS and the way the STIG is written out, that's allowed, but using MD5 isn't allowed, just because of the MD5 because of FIPS.
That's right.
All right.
The way Postgres uses MD5, it actually takes your password, it appends the username, it does an MD5 hash, and that's what gets stored. And then when you authenticate, it passes a token, not exactly a great token. It's, I think, 4 characters, and so it's not very long salt. But basically, that salt gets appended to the hashed password, and then that whole thing gets hashed. And so in terms of like birthday attacks on passwords, because of the concatenation of the username, you're not going to actually guess someone's password by doing that. But what you do find, the problem that you have is you've got multiple Postgres instances, and the only way someone's actually going to get this hashed password is to be able to break into your Postgres instance in the first place. So this is why I say it's like you're already kind of owned. Mm-hmm. Someone's got your password out of the shadow PG shadow table. The only thing they can do with it is if you've got another Postgres instance with the same username and the same password. If it's a different username and the same password, it'll be a different hash. And if it's the same user with a different password, it'll be a different hash. But if you have the same user and they reuse their password across 2 Postgres instances, and one of your instances gets hacked somehow and they manage to get this hash, now they can get into your other Postgres instance.
Thank you.
Yes?
I recently had the pleasure of working with the STIG questionnaire. You're right, it's pretty boring and tedious. And I actually have a question about a particular item from that questionnaire, which is really confusing to me as a DBA who is managing PostgreSQL. It's literally V3233, which states the DBMS by default shut down upon audit failure to include the unavailability of space for more audit log records, or it must be configured to shut down upon audit failure. So what essentially it means is if auditing facility for DBMS runs out of space, then DBMS must shut down. For business, that's a bit impractical because you would cause...
And this is why what I said earlier is that you've got to look at this as which of these rules actually apply to your business. If your audit logs get stopped because of no disk space, you might care enough that you want your database to shut down because you really can't afford to have anyone accessing something without an audit record getting created. But if your business isn't worried about it at that level, then you just basically say, we're going to skip that rule.
Okay, and auditors are generally okay with that because usually part of the tuning the database towards these requirements is essentially compliance.
Well, again, it depends on the environment you're working in whether they're going to find that an acceptable answer or not. I mean, they may find that usually you look for mitigations, and so your mitigation might be that it's not going to shut down, but I've got an alert set up that will tell me when the database, when the storage is 90% full or something, right? So you know, they'll say, all right, you're okay with being not compliant to this rule because you've got this mitigating method.
Okay, fair enough. Thank you very much.
I think we're out of time. So if any other questions, feel free to track me down. I'm here for the rest of the conference. I'll be at lunch. Thank you.
For you guys who are looking to go to lunch, please accept your replies, so off your timing.
What?